Today we are going to be looking at finding the zeros of our functions. So here we have three groups. X minus 2, we want to set that equal to 0. X plus 1 equal to 0. And x plus 3 equal to 0. When we go to solve these, we would add 2 to both sides. So that means x equals 2. Subtract 1 to both sides. X equals a negative 1. If we subtract 3 to both sides, x equals a negative 3. So these are the zeros that we're working with. These are the points that they would intersect at the y, or the x-axis. So these points up here that we plotted. Okay, let's look at this problem. X minus 7 equals 0. X minus 5 equals 0. X minus 3 equals 0. So we'd have to add 7 to both sides. So x equals 7. Add 5. X equals 5. Add 3. X equals 3. So these are our zeros, what x equals, where they would cross on the x-axis. Last one, we have x plus 1 equals 0, x minus 1 equals 0, and x plus 3 equals 0. So here we would subtract 1 to both sides, so x equals a negative 1. Add 1 to both sides, so x equals 1. Subtract 3, so x equals a negative 3. So here are our zeros, meaning that's where they cross on the x-axis. Page over. Factor theorem. Factor theorem is when x minus a is a linear factor of a polynomial if and only if the value of a is a 0 of the related polynomial function. Okay, so here we are going to be working backwards. We know what the zeros are, we just need to write them into factor form. So if x was at negative 4, we're looking at x plus 4. X equals negative 2, so x plus 2. X equals a positive 1, so x minus 1. For this one, x equals a negative 2, so it's x plus 2. Here, x equals a positive 3, so that's x minus 3. And we have the same thing. If we have two of the same answer, we square it. Last one, x equals a positive 2, so that means we have x minus 2. X equals a negative 3, so x plus 3. And then we have x equals 0, which means there is just a variable by itself. Multiple 0 is a repeated 0. So for instance, if we have x plus 2 times x plus 2, our repeated 0 would be x equals negative 2. Multiplicity is equal to the number of times it occurs. So let's look at this problem. We have a 0 at x equals 2. X equals a negative 1. This is also an x equals a negative 1. And this 2 tells us it happens one more time. So there's a zeros at negative 2, or sorry, positive 2 and a negative 1. And there's a multiplicity of 3. And that's when we have x equals negative 1. So when x equals negative 1, there's a multiplicity of 3. It shows up 3 times. First, we need to factor this problem. So if we go to greatest common factor, there's just a 1. So we can pull out an x. So we're left with x squared minus 4x plus 4. Factors of 4, 1 and 4, 2 and 2. So if we factor this, we get x we want the 2 and the 2, and make them both negative. So that means here we have x equals 0, x equals a positive 2, and x equals a positive 2. So we have when x equals 2, it's a multiplicity of 2, meaning it shows up 2 times.